Now we'll be discussing the topic of interpolation, which will be the first topic of the numerical methods videos. And this will be the short general introduction to interpolation. So, first question, what is interpolation? With interpolation, you are given a number of well-known discrete data points, and you're asked to estimate the value of the values between these data points. So you can, for example, do this graphically by just plotting the points on a graph and drawing a line through it. The most common method of interpolation is polynomial interpolation. And here you try to fit a polynomial through the data points. And if you are given n+1 data points, you can fit a polynomial of degree n through these points. So an example of this is given in these 4 figures. The first, on the top left, you'll have 2 data points, and therefore you can fit a polynomial of degree 1, thus a straight line, through these points. The second plot, top right, you'll have 3 data points with a second order polynomial, therefore a parabola going through the points, and so forth and so forth. You can go up to a very high order, and these figures were created in MATLAB, as will be most examples in these lecture videos. And the equations for the polynomials are given in the figures titles. So recall the general formula for an nth order polynomial that is equal. So fn of x is equal to a0 plus a1x plus a2x squared plus etc. etc. So here we have the coefficients ai, and we have we multiply it with x to the power I, and you can represent this in sigma notation as well, as is done underneath that. So if we want to find this polynomial, for this we have to solve a set or a system of linear equations. So if we have n+1 data points, let's present them as xi, yi, where I ranges from 0 to n. Then we can have, then we can represent our linear set of equations as this. We can also put this in a matrix form. But basically, your unknowns are going to be your coefficients a. You'll have n+1 unknowns and n+1 equations. So you can solve it. But such a system becomes, or is very ill-conditioned, especially if you go up to larger values of n. And you'll have a very high order polynomial that you try to fit through the data points. So your function will oscillate a lot in between those data points if you go up to a high order, and therefore your errors are going to be quite large, and it's just not a very nice way of doing it. So alternatively, you can represent a polynomial in a different way from the last slide, the expression on the last slide. So I will be discussing 2 different methods of performing polynomial interpolation in the subsequent videos. So the 2 methods are Newton interpolation and Lagrange interpolation. And these 2 are especially well suited for computer implementation.